Okay, so today in algebra class, we're going to talk about solving inequalities. We're going to get into chapter 2. I bunched a few of the sections together because this is similar to chapter 1 in a few ways. For the video, as I go through slides, if there is just words on it, in class my students would take those notes and I'd give them time to write those down. For the sake of keeping the video shorter, if there's a slide with just words, with just notes, I would pause the video so you can write it down, and then you can start the video back once you have it down and listen to what I'm saying, because I'm going to go directly into the material on each slide. So we're going to start this slide talking about inequalities. So like I said, when this comes up, I would pause the video if you're watching, write down what's going on, and then start it back so you can hear what I'm saying. So the one key vocabulary word in this section is inequality. And inequality is when two values being compared are not equal. So in chapter 1, we dealt with equal signs the whole time, talking about equations because equations have equal signs. Now we're going to talk about inequalities, which are two values that are being compared that are not equal. Okay, so for this section, there will be 4 types of inequalities that we deal with, mainly. So again, I would pause the video, write these down. The 4 main inequality symbols are greater than or equal to. Okay, so if it has the greater than symbol with a one line underneath it, that is a greater than or equal to, less than or equal to, and less than. Okay, so again, less than is your arrow pointing to the left, and less than or equal to has the single line underneath to indicate that it is also equal to. So it could be less than or equal to. And these are the phrases that might go along with each symbol. So again, I'll pause the video, make sure I'm writing these down. But these are, like in word problems especially, you need to know which phrase goes with each symbol, because you might have to turn a phrase into a inequality sentence. So our 4 inequality symbol phrases, if we have the greater than, obviously you have is greater than, and you also might see is more than. With the greater than or equal to, there's a few that are a little bit different. So there's is greater than or equal to, which is the obvious one. Is at least, so that means it can go all the way down to a certain number that's at least, and then it can be anything greater than. So that's greater than or equal to is the same as at least, or is no more than. Okay, is no more than is also represented by greater than or equal to. Or is no less than, I'm sorry. Is no less than is also greater than or equal to. So those are the 3 main phrases that you might see with greater than or equal to. Less than or equal to symbol, you have is less than or equal to. Is at most, so again, you can go all the way up to a certain number, and at most, that's the number you can get to, or it can be anything less than that. So that's why less than or equal to can also go with at most, or is no more than. So is can go all the way up to something, but it can be no more than that. So that's also represented by less than or equal to. And then your less than symbol can be is less than or is fewer than. Okay, either of those also represent the less than symbol. So let's get into some examples that you might see to start. Like I said, you might be given sentences and be asked to make those into inequality sentences. So the directions say write each sentence as an inequality. So part A, it says a number W minus 3.5 is less than or equal to -2. So the first 3 words, whenever you have problems like this, you just need to take it part by part. So first part says a number W. So we don't know what that number is, and they tell us that they want it represented by W. So that's what I'm going to do. My first thing will be put the variable W into my inequality phrase or inequality sentence. Okay, a number W minus 3.5, next key part, minus 3.5. So I'm taking I'm subtracting 3.5 from W, so W minus 3.5. And then we have our phrase, inequality phrase that we talked about in the last slide. Is less than or equal to. So you have to make sure you understand which symbol that is. Is less than or equal to would just be the less than sign with the one line underneath it to represent less than or equal to. And then lastly, it's less than or equal to -2. So -2 is what we finish that out with. So part A, that turns into W minus 3.5 is less than or equal to -2. Part B, it says 3 is less than a number n plus 5. So again, just take it part by part and write it left or right as you go. 3 is less than, so is less than is our phrase, so we just use the less than symbol. A number n, so again, they tell us the variable they want us to use, a number n. So I'm going to use the variable n plus 5, and then I do addition plus 5. So there's your inequality for part B. 3 is less than n plus 5. Okay, last one, C. 0, okay, I'm going to start with the very beginning, 0. So I have the number 0. Is greater than or equal to. Okay, is greater than or equal to. I'll use my greater than sign with the line underneath to represent or equal to. Twice a number plus 1. So two key things in this one. First, it says twice a number, and they don't give you the variable they want you to use in this problem. If they don't give you the variable, they just say twice a number, you can choose whatever variable. Usually you'll use n, just because number starts with n. You can use x, you can use y, you can use whatever, but that is usually what you'll see if they don't give you the variable to use. So also, twice a number means 2 times a number. So if you see twice, that means 2 times a number. So the way I would represent that would be 2, and then my variable, n. Because something that we've talked about is a number and a variable right beside each other, that's multiplication. Okay, if there's no symbol in between them and they're right beside each other squished together, that's multiplication. So twice a number is represented by 2n. Plus 1. So lastly, we have plus 1, and that's how we finish off that inequality. So those are a few examples of writing those inequalities and how to break down the sentence as you go through it. So then I usually will do on your own. So again, if I'm you at home, I would pause this video, try these on your own. So I'll give you a second to pause it. But as soon as you are done, you'll come back here, and I'm going to give you the answers to each of them so you can see if your answer was correct. So the first one, a number B is fewer than 30.4. So that would be represented by B, fewer than is less than, sign 30.4. So B is less than 30.4 is the first one. Okay, so the second one, B, you might have got confused with is at least. So if you refer back real quick to a couple slides ago, is at least, you can see represents greater than or equal to. So when I come back to this one, the is at least, so it's 7, is at least, greater than or equal to sign. Twice a number, so like we said, twice a number could be 2n minus 4, minus 4. So that is your part B, how you would represent that one. Alright, so let's look now. Again, this is more notes, so you would pause the video and write this. It says when graphing inequalities, an open circle represents greater than or less than, and a closed circle represents greater than or equal to or less than or equal to. So sometimes you'll be asked to graph these on a number line. Okay, if that's the case, you have to use an open circle when talking about greater than or less than. So you also use a closed circle when we're talking about greater than or equal to or less than or equal to. And I'll show you what that means on a number line, how that will look. So let's look at examples of those. So it says graph each inequality. We have part A, which is part A and part B. Part A is y is less than or equal to negative 3. So y is less than or equal to negative 3. Whenever you do this, you're just going to make your number line. And you're going to have to, it doesn't matter where you start, what your intervals are. All that matters is you have negative 3 on that graph. So I usually would put just negative 3 in the middle, and then go left or right by 1 or 2. So negative 4, negative 5, and then on the right side, or right side, it'll be negative 2, negative 1. Again, you can extend that if you need to. Main thing is just have negative 3 on there. So y is less than or equal to negative 3. This number line is going to represent any number we plug in for y that will make this true. So if I'm talking about y is less than or equal to, remember, less than is always to the left. So less than numbers would be negative 4. Now, negative 4 is less than or equal to negative 3. Negative 5 is less than or equal to negative 3. Everything to the left of negative 3 is less than. But the main thing to remember on this is it says, if you refer back to the last slide, you have to use a closed circle for less than or equal to. And the reason you do that is negative 3 also satisfies this equation, or inequality. If you plug a negative 3 in here, it's still true. Negative 3 is less than or equal to negative 3, because it's equal to. So what that'll look like is you're going to make a circle, closed circle. All it means by closed circle is it's filled in. So like that's filled in right there. And then you draw an arrow to whichever side the numbers you're referring to work. So if it's less than, that means you're going to the left. So that would be what your arrow looks like. So you have a closed circle on negative 3 and an arrow pointing to the left. Okay, so that's the first one. Let's look at the second one. We have 2 is less than x. So I'm going to go ahead and give you a tip on this because this will throw students off a lot. If your variable is not on the left side, you might want to switch it to the left side because it'll make it easier to read. When you do that though, if you switch these positions, you also have to turn the inequality. So if this goes from 2 is less than x to x is greater than 2. Those read the same and they mean the same thing. You just have to make sure you flip it, okay, if you're turning the whole thing, because this makes it easier to read for you to graph. So if we have x is greater than 2, I'll make my number line. I have to make sure 2 is on there, so I'll put 2 in the middle, and then numbers to each side, 3 and 4 to the right, 1 and 0 to the left. So again, if I have x is greater than 2, I need all the numbers that I can plug in to make this true. So remember, if it's not or equal to, if it's just greater than or less than, it's an open circle. Okay, so that means on 2, I'm making an open circle. So that's what an open circle looks like. I didn't fill it in with color. Greater than 2 means I'm going to the right. So greater than 2 would look like that. So that's your answer for part B, an open circle on 2 with a line going to the right. So then I'll show some on your own. Again, I'll give you a second. You should pause the video to try each of those on your own. See if you can get them. As you're pausing the video to do that, I'm going to draw the number lines up here for each. Okay, so hopefully you've taken a second to try those. As you can see on this, 1.4 I need to put in the middle because 1.4 is less than or equal to g. Again, if I were doing this problem to make it easier to read, because I know a lot of students, middle school students especially, like to read from left to right, I'm going to turn that around, and when I do that, it'll be G. I need to twist my...
Excuse this interruption. Sixth graders, please bring your copy of Number the Stars to Mrs. Klein's English class.
I twist it around. When I twist that around, I need to flip my inequality sign. So it goes from less than or equal to greater than or equal to 1.4. So if I have 1.4 again, it doesn't matter the intervals you do. You can do 2.4, 3.4, you can do 1.5, 1.6. Doesn't matter as long as you have the 1.4 in the middle. Okay, and then I'll just do 1.5, 1.6, on the left side, 1.3, 1.2. So, once I flip this around, I have G is greater than or equal to 1.4. So if you did this, you should have gotten a closed circle on 1.4, because it's or equal to, going to the right because it's greater than. Okay, so that's what your graph would look like for that one. For the second one, we have x is greater than 0, so I'm going to put 0 in the middle, 1, 2 on the right, -1, -2 on the left. We have a less or is greater than, so it's not or equal to, so that means it's an open circle on 0. Greater than is going to the right. So that is what your symbol should look like, or your graph should look like for that one. So again, this is a large slide about notes. So I would take a second, pause that, write those down. Once you've written them down, I'll read this. It says, in this section you'll be solving inequalities. They are solved the exact same way as solving equations, by using opposite operations to get the variable variable by itself. So, just like chapter 1, if you have a variable you're solving for, you leave it put. It doesn't move. Everything else needs to go to all numbers need to go to the other side of that inequality symbol by opposite operations. Important note, the only difference is when you multiply or divide both sides by a negative number, you must flip the inequality symbol. That's what messes with students the most. That's what trips them up. You have to remember, if you are multiplying or dividing, so it has nothing to do with addition or subtraction. If you're adding or subtracting, don't worry about this. It doesn't apply. If you're multiplying or dividing by both sides by a negative number, so if you multiply or divide by a positive number, you're fine. This still doesn't apply. Only applies when you multiply or divide by a negative number. Okay? If you do that, you have to flip the inequality symbol. So the whole equation, or the whole inequality doesn't flip, just that symbol flips. So everything on the left, everything on the right stays where it's at. The inequality symbol is what flips. So let's look at what this might look like as far as solving inequalities. First, this says, when solving inequalities, if the variables cancel out. So this is also talking about kind of what we talked about in chapter 1, where if the variables cancel out and the numbers that match, if the numbers match on both sides, it is infinite solutions. If numbers didn't match in the first section, it was no solution. So this is along the same lines. If you're solving inequalities, the variables cancel out. The remaining inequality, if the remaining inequality is true, so like if they cancel out and all you have left is 4 is greater than 3. That's true. 4 is greater than 3. There are infinite solutions. Okay? Also, if the remaining inequality is false, so if what's left isn't true, so if you end up with 2 is less than 0, that's not true. So if that's the case, there are no solutions. So that would be your answer if those happen to pop up. Alright, so let's look at some examples and read the directions that go with it. This one says, solve 6 minus 3 is less than 7 plus 4x and graph its solution set. So 2 parts. First thing we need to do is solve it. So I have 6x minus 3 is less than 7 plus 4x. Okay? Just like section 1 or chapter 1, whenever you see x's on both sides of that inequality sign, the very first thing you should do is get them to the same side. Okay, you need to do opposite operations to get them on that same side of that inequality symbol. It doesn't matter which way you go, you just have to make sure you take them to one side. I could take the 6x over here or the 4x over here. A lot of students prefer to have the x's on the left side, which is fine. If that's what you want to do, that means we're going to move the 4x to this side. To do that, remember this is a plus 4x, so we're moving the whole thing by opposite operations. So plus 4x, to do the opposite, I subtract 4x, and I do it from the left side as well. My positive 4x and my negative 4x cancel. Something that a lot of students get confused with. Remember, a minus sign and a negative sign are the same thing. Okay, in math, those are the same thing, and a lot of students forget that. So those canceled. On the left side, I'm going to do this math. 4x minus, or 6x minus 4x. First of all, you subtract the numbers. 6 minus 4 is 2. Remember, that is not the only thing that comes down, though. You also have to bring the x down. Those x's don't cancel out. They represent something. They represent an unknown number. So they come down as well. So 6x minus 4x is 2x, not 2. Okay, 2x. The other thing, and once you've done that, once you've worked out your x's, you bring down what you haven't used. We haven't used the minus 3, so minus 3. And we haven't used the less than 7. So that's the new inequality we have. So once we have our x's combined, we start solving this just like we would an equation, by getting that x by itself. So first thing we do is add 3 to both sides, because we have minus 3. First thing we need to move, or again, remember the x is what we're keeping by itself. All the other things are moving to the other side. So first I'll start with the minus 3. I add 3, and I add 3 to both sides of the when I say both sides, that also confuses students. I mean both sides of that inequality symbol. So I added it to the left side, now I also add it to the right side. The minus 3 and the plus 3 cancel. Okay? I bring down the 2x on the left side, bring down my less than sign. 7 plus 3 is 10. So now I have the inequality 2x is less than 10. Okay? Last step will be to, this is multiplication, remember, because they're right beside each other, 2 times x. So I do the opposite, which is divide by 2 on both sides. So I divide by 2, the 2's cancel, x comes down. Remember, the important note on the couple slides ago does not apply here, because we did divide, but we did not divide by a negative number. So I still keep that inequality symbol as less than. So x is less than, 10 divided by 2 is 5. So that's your final answer. X is less than 5. That's your, once your x is by itself, on that left side of the inequality symbol, if there's nothing else on the same side of the inequality symbol as x, you're done. So that first part's done, but it also says graph its solution set. So what that means is I need to do the number line. So I'm going to make a number line, put 5 in the middle, 6, 7 on the right, 4, 3 on the left, and we just break it down like we did before. First of all, 5 is what we're looking at, and it's x is less than 5. So that less than symbol does not have or equal to. So remember, that means it is an open circle. Okay, open circle on 5. If it's less than, that is talking about all the numbers less than 5. So I go take my arrow to the left. So there is your solution set graphed. You have the open circle on 5, and the less than means we're going to the left with the arrow. All right, let's look at another one. We have 4x is greater than 4 times x plus 2. So we write that down. We have 4x is greater than 4 times x plus 2. So first thing, when you see these parentheses, you need to distribute that 4 through. So what that means is I'm going to multiply 4 by each term on the inside. So that means I have to multiply 4 by x and multiply 4 by 2. So I'm going to bring down that left side, 4x is greater than, and I'm going to do the math on the right side. 4 times x is 4x, and 4 times 2 is positive 8, so I put plus 8. So now, we have x's on both sides of the inequality, so again, we need to get those on the same side. So to do that, I'm going to move my 4x on the right side to the left. This is a positive 4x, so I'm going to do the opposite, which is minus 4x on both sides. The 4x and the positive 4x and the negative 4x cancel on the right side. But now you'll also see we have 4x minus 4x on that side. If that's the case, those also cancel out. So if everything cancels out on the left side, all that's left is 0. Bring down my greater than symbol, and I bring down the 8 that's left on the right side. So, if we're here, we have 0 is greater than 8. Remember what a couple slides ago said. If the variables cancel out, which they did in this case, what is left, if it is true, it is infinite solutions. But if it is not true, that means that it is no solution. So, 0 is greater than 8. Is 0 greater than 8? No, it is not. So therefore, my answer to this is no solutions. So no solution is my answer to that because 0 is not. This is false. 0 is not greater than 8, so therefore, no solution. Graph its solution set. There's nothing to graph because there's no solutions to it. So that is your final answer. Just no solution. All right, let's look at one more that might be a little more complex. So we have y plus 5 is less than 7y minus 6, and then parentheses y minus 1. Okay, this is a good problem to go over because there's a misconception that I see students make a lot in this problem. First thing again, you see these parentheses, you need to distribute. Here's where students forget to do a lot. This right here, that negative or that minus sign goes with that 6. So you have to distribute a negative 6 through. So when you multiply, you're multiplying negative 6 by each number inside. So this is negative 6 times y and negative 6 times negative 1. Again, that minus sign and negative sign are the same thing. So that is negative 1. Okay? So I'm going to bring down everything I'm not using. Y plus 5 is less than 7y. Negative 6 times negative y is negative 6y. Negative 6 times negative 1, remember, negative times a negative is a positive, so plus 6. So now we have y's on the same side. Remember, if you've got y's on the same side, you should combine those right away. So I'm still not doing anything with the left side. I'm going to bring it down. Y plus 5 is less than 7y minus 6y just leaves you with 1y. Okay, 1y. And I bring down my plus 6. Okay, now we have, and again, if it's 1y, you can just write it as y. It's the same thing. So now we need to get the y's on the same side because they're not on the same side. So to do that, I need to move this y over here. It's a positive y, so I'm going to subtract y from both sides. So as you can see, that y is going to cancel with the negative y. Same on the left side, they both cancel. So we have another problem where all the variables are canceling out. We bring down what's left. We have 5 is less than 6. So then you check to see if that's true. Is 5 less than 6? Yes, it is. So therefore, my answer is infinite solutions. Infinite solutions is your final answer. So I'm going to leave you with these. I want you to try each of these 4 on your own. Because I've got a class coming in, so try those 4 on your own, see if you're getting a hang of this.